So we got a little bit of review up here. Rationalizing denominators. You guys did this as video notes after your test last time. So a fraction is in simplest radical form when the only radical sign is where? Numerator. We cannot have radicals in the denominator. So if we look at my examples down there, first one's okay. It's got the radical up in the numerator. How about that second one? Third one? No. Fourth one? Good. Last one? No. We cannot have that radical in the denominator. So what we did last time is how did we get the radical out of the denominator? Yeah, multiply top and bottom by that radical. So in this case, you would have multiplied top and bottom by radical 6. My little graphic there shows you we do that because it's the same as multiplying it by a 1, because anything over itself is a 1. So my little note, always the radical in the denominator. Sometimes you'll have a radical in both the numerator and the denominator, so you just got to remember it's always the one in the denominator that you're multiplying by. So what I want you to do, because it's review, take a couple of minutes, do those first two examples down there, practice the skill, practice your multiplying radicals, because that's all going to be on your quiz Friday. All right, so we should end up with 4 radical 6 minus 3 radical 2 for that last one. How do we do? All right. What about ones like this, where the radical is not the only thing in the denominator? This time we have radical 5 minus 2. What could we do to get rid of that? Well, let's think here. If I multiply by radical 5 in the denominator, radical 5 times radical 5 would be 5. But when I multiply here, I would get minus 2 radical 5. So does it really get rid of my radical in the denominator? No. Okay. Does anybody have any ideas? Any guesses? Lizzie? Multiply it by itself. Okay. Well, let's see what would happen if we did that. Radical 5 minus 2 times itself. So radical 5 times radical 5 gives me 5, minus 2 radical 5, minus 2 radical 5, plus 4. So we still would have a radical. So that's not going to work. Any other guesses? Morgan? Yes. You have to find what we call the conjugate. Conjugate means you just change the sign in the middle. So instead of radical 5 minus 2, we're going to want to multiply it by radical 5 plus 2. Because remember, if we multiply that radical 5 minus 2, there's my denominator. If I multiply it by its conjugate, which means I just change that sign in the middle, radical 5 times radical 5 gives me 5. Then I have positive 2 radical 5. Minus 2 radical 5, and then I get a minus 4. And then what happens with my radical 5s? Then they are gone. So the conjugate gets rid of that radical term in your denominator. So if you have 2 terms down there, you have to multiply it by the conjugate. Whereas if you just have 1 radical, you just multiply by that radical. So to rationalize a fraction with a binomial denominator, first determine the conjugate. And again, the conjugate only changes that sign in the middle. Nothing else changes about it. So then second step, multiply numerator and denominator. You multiply those by the conjugate, just like before we multiplied it by the radical. And then step 3, if necessary, you're going to simplify, as always. So let's take a look at example 4. Our denominator is 5 plus radical 3. So what would our conjugate be? 5 minus radical 3. So we're going to multiply both the numerator and the denominator by that 5 minus radical 3. So up top, I would end up with 30 minus 6 radical 3, just multiplying the 6 times the 5, and then the 6 times that negative radical 3. In the bottom, 5 times 5 makes that a 25. Do I even need to bother multiplying by the radicals? No, because we know it's going to cancel out. That's the whole reason we're using the conjugate. So then I'm just going to multiply the radical 3 times the negative radical 3. That would give me negative 3. You don't have to do the ones for the middle. You can if you still need to. That's fine. But you don't have to. With the conjugates, you can just multiply the first and multiply the last. So we get 30 minus 6 radical 3 all over 22. And then can we reduce those all by a number? Yes, all by 2. So 30 divided by 2, 6 divided by 2, and 22 divided by 2. So 15 minus 3 radical 3 all over 11. All right, you go ahead, try those next two. Figure out the conjugate, just change the sign of the denominator, and then multiply. That last one, we should end up with 13 minus 4 radical 3 all over 11. So on the top, we still had to do full distributive. So we ended up distributing 4 times total. Bottom, just the first and the lasts. So in our last thing with radicals, before we get into imaginary numbers on Friday. So if we recall, if I'm multiplying the square root of x times the square root of x, that ends up being the square root of x squared, which simplifies down to x to the first. So what we can take away from that is x, or the square root of x, if I square it, it just cancels each other out. That radical sign is canceled out by the square. So the same thing would happen here. So this would end up being 5x. Because again, that radical sign gets canceled out by the 2 exponent there. Same thing happens with our cube roots. So cube root of x times cube root of x times cube root of x would be the cube root of x cubed, which would just end up being x, because that cube root and cubing something, those cancel each other out. So for example, this one would just be x. This one over here would be x plus 1. So that cube root, cubing something, knocks each other out. So squaring a number is the inverse of taking the square root. And then cubing a number is the inverse of your cube root. Just kind of like addition and subtraction are inverses. They kind of cancel each other out. These things cancel each other out also. Squaring, and then square root, cubing, and then cube root. What if I was taking the 4th root of something? What would cancel the 4th root out? To the 4th power. What would cancel the 5th root out? To the 5th power. So just whatever that index number is, whatever root you're trying to find, raising it to that exponent is what's going to cancel it out. So solving radical equations. Step number 1 is you want to isolate your radical. So you got to make sure it is by itself as much as it possibly can. Then you'll raise both sides of the equation to the power equal to the index, meaning if it's a square root, you square both sides. If it's a cube root, you cube both sides, that kind of a thing. Simplify and solve. And then very important is check for extraneous roots. With your radicals, there's extraneous roots all the time. So you got to make sure you're checking all of your equations to see if your root doesn't work out. So let's take a look at example number 1. My radical is not isolated yet. It's got that plus 8 there, and it's got that 2 out in front of it, so we need to get rid of those first. So I'm going to subtract my 8 first. So when I do, I get a negative 4 over there on my right side. And then how do we get rid of that 2 in front of that radical? Divide. So I get the square root of 2x minus 6 equals negative 2. Now my radical is isolated. It is a square root. So I'm going to square both sides of my equal sign. So again, on that left side, squaring and that square root sign, they just cancel each other out. So I'm just left with the 2x minus 6 now. Negative 2 squared gives us what? 4. And now we got a nice easy linear equation to solve. I'll add our 6 first. Divide by 2, so we get x equals what? 5. So now we have to do a check. So as I said, a lot of times radical equations, the answers don't work out. So if I go and I plug my 5 back in, two times 5 under the radical gives us what? 10, and then minus the 6 makes that a 4 under the radical sign. So what is the square root of 4? And then times the 2 that was already there. And then plus the 8 gives me a 12. 12 doesn't equal 4. It doesn't check out. So this one has no solution. All right, let's try the second one. Is my radical isolated yet? Nope, I got that 5. So let's divide by 5 first. So that gives me the cube root of 4x plus 3 equals 3. So what am I going to want to do next? Raise it to the third power. This one is a cube root. So to undo my cube root, I'm going to want to raise it to the third power. So I get 4x plus 3, and then what's 3 cubed? 27. And again, now we have a nice easy linear equation. Subtract my 3. Divide by 4, and what does x equal? 6. So go ahead, check to make sure the 6 works. So 4 times 6 plus 3 gives us a what underneath that cube root? 27. And again, it's cube root. Some people before forgot it was cube root. So cube root of 27 is 3. So 5 times 3 gives me 15. So yes, it does check out. All right, let's take a look at number 3 on the back there. So what should our first step be? Add the x over. So square root of x squared minus 21 equals x minus 3. Now what? Square both sides. Great job. Square both sides. So when we square both sides, our radical is gone. But when you square x minus 3, do not simply write x squared minus 9, because that is not correct. X minus 3 squared, you have to use your distributive property, and you end up with a trinomial. Should end up being x squared minus 6x plus 9. When you distribute everything out, combine your like terms, you get that middle term of minus 6x. So what happens with my x squareds? They're going to cancel. Because I would try to subtract 1 to the other side, and it just ends up canceling with that one also. So x squareds just kind of cancel. So then I'm going to bring my 9 over by subtracting it. So negative 21 minus 9 gives me a negative 30. Divide by our negative 6, and what do we get? 5. So go ahead, check 5 quickly. All right. 4, this one has 2 radicals, but the 2 radicals are already isolated, so what should we just do? Square them. So 5x plus 1 equals 4x plus 3. Subtract my 4x, subtract my 1, and we should get x equals 2. Which, does that work? Let's see here. 5 times 2 plus 1 is square root of 11. 4 times 2 plus 3, is that 11 also? Yep. So radical 11 equals radical 11. That checks out. So x equals 2. All right, let's go down here and take a look at my first number 5. So that radical on the left, is that completely isolated? No, it's got that 3 there. But, you don't have to write this yet, but if I divide by 3, does it really make my problem any easier? No, because then I've just created a fraction. That's not going to help me any. If we look at this radical on the right side, that one is isolated. So these ones are as isolated as they're going to get. So we would go ahead and go to our next step of squaring both sides. When I square that left side, though, you got to remember, this 3 here is also going to be squared. So that would turn into 9x. Because again, that square just cancels out that radical sign there. And then my radical's gone over there on the right side. So subtract my 5x, divide by 4. And we get x equals 8. So go ahead, do your check, see if 8 works. All right, and then our last one there, second number 5, looks a lot like the first number 5. So what should we just do? Cube both sides. Remember to actually cube that 2 first, so it does become 8. And I put the x minus 1 in parentheses because I would have to multiply that 8 times both the x and that minus 1. So we get 8x minus 8 over there on that right side. Add my 8 over, subtract my x. So we get x equals 2. So doing my check. Cube root of 8, we're going to see that equals 2. Cube root of 1, because 2 minus 1 gives me 1. And it will. Cube root of 8 is 2. Cube root of 1 is 1, but times 2 makes it still 2. So x equals 2.